session. We have real-time graphs with ColdFusion, GraphQL, and WebSockets by Dave Ferguson. Over to you, Dave.
Awesome. Thank you. Welcome, everybody. So we're going to go through a whole bunch of fun stuff today, teach you a little bit about a lot of things, and hopefully give you a really cool look into some interesting tech that you may not have thought about using before in some very cool, interesting ways. So today, like I said, we're talking about real-time graphs using ColdFusion, GraphQL, and WebSockets. If you haven't heard of any of those, I will educate you along the way with what those actually are. It'll be good times. So a little bit about myself. I remember a time when Google wasn't around. I do one of the people that helped write the training and certification for ColdFusion. And I am a 4th degree black belt in Taekwondo and a 2-time world champion. So that's what I do when I'm not coding or working in front of my computer. It's good to have something that's physical when you sit stationary all day. So wake up, you might want to learn something. So we're going to go over what GraphQL is, how GraphQL and ColdFusion connect together, a brief overview of WebSockets. I'm not going to go too detailed as there are thousands of presentations out there. Before that, will show you how to set up WebSockets from the start. So charts and graphs using the built-in CF chart, and we're going to show how to put it all together to do something useful and cool, hopefully. So when coming up with this presentation, I was like, what is a good way to show somebody what GraphQL does or could do? Because just explaining GraphQL on its own doesn't really do it much justice. You really need to have a good use case of why you would want to use GraphQL. And in playing around with a few things and some stuff I've done in the past, I realized that I actually had built something prior that I could inject GraphQL into and make it a little more robust. So what we're going to do is I'll explain all the parts of it and then show you how I did it, where we're actually taking data from a video game, specifically Apex Legends, taking some data from that game, storing it in a database, using GraphQL to react to the data, and then using a dashboard to display the data. So we're able to then, using some cool, interesting tech, literally watch a video game being played out through data. So that's the end task is what we're going to do. And I'll show you how that all melds together at the end after we explain all the little pieces and parts. So like I said, just a little bit of tech going on and what we're going to be talking about today. And feel free to ask questions along the way. And I will do my best to answer or save them for the end, one of the two. So at the core of everything is ColdFusion. Its interaction with everything makes a lot of this super easy. So obviously said we're going to be using GraphQL. It's a query language for APIs and a runtime. We're using charts and graphs from using the built-in CF chart using Zing charts and some of its underlying functionality and capabilities. Built-in WebSockets as well for two-way communication and just a relational database. Insert your favorite database here to make this work. Nothing specific there. So GraphQL. So GraphQL is kind of a misnomer. So is GraphQL a database? This is where if we were everybody in the room, I'd have you raise your hands. So we can't do that. So GraphQL, is it a database like MongoDB or MySQL, or is it a query language for runtimes and APIs? Kind of gave that one away earlier, but it's actually the latter. It's actually more of a runtime for getting data. It sits between your client and your data sources, like database, REST APIs, microservices, etc., to facilitate getting to your data easier. It doesn't add too much complexity if you set it up properly, but once it's set up, then everything just becomes easy. And also it's important to know that it's actually not a graph. So although its name is GraphQL, it is not a graph at all. But you can really think of it if you're used to SQL Server, or I'm sorry, SQL Server and Microsoft SQL Server, and other databases that have this. think of GraphQL as a view, and so when you're querying GraphQL, you query the view, which the view knows how to go out and get the data. So it's a kind of the same thing, but on a much different level, where that view could then tap into other things just beyond its own data. And like I said, GraphQL is not a database, but it tries really hard to be. It doesn't really store anything. It just gets it for you. So what's the overall role of GraphQL? Well, like I said, think of GraphQL as a translator. So your application is, I only want usernames and orders. And GraphQL is like, okay, fine. I'll go out to your configured items and get those things for you and bring them back. And only that, instead of grabbing a ton of extra things. It simplifies down your data going in and out. It responds with a JSON payload. And like I said, since it can tap into multiple different things, you don't need to know, or your application doesn't need to know how to tap into all those other things. All your application needs to know is, how do I query GraphQL? And the main important thing is GraphQL really doesn't care about your database. Since it can tap into so many different things, SQL Server, MySQL, Oracle, Mongo, Firestore. It can read APIs for SOAP and REST. Lots of different things. It gives you the flexibility to add all this extra stuff into your system without actually configuring your application to read all this stuff or understand or deal with the multiple different types of data returns you're going to get from dealing with all of these systems. It's like you query a REST endpoint, you're going to get JSON back. You query a relational database. If you do this on their own, you query a relational database, you're going to get a query object back. Well, GraphQL takes all that and normalizes it, so you always deal with the JSON return, which you could then easily turn that JSON back into a query object if you wanted to in ColdFusion. So it definitely allows you to mix and match where all your data sits without having to figure out where exactly it sits on your application side. And it's all pre-configured and pre-set up in GraphQL. So yeah, you kind of read that right. GraphQL can read an API and return the same results as if it was pulling directly from SQL Server. It can even combine multiple REST endpoints. So if you have data sitting in two different endpoints and you want to query them both simultaneously, GraphQL can do that. And it can give you that result back instead of your application having to tap two different APIs simultaneously and get one, then the next. It'll do it for you. And it makes it super simple, like I said, to add all of this into your application without too much effort. Granted, all the effort and configuration is done on the GraphQL side, where the ColdFusion side is pretty simple, relatively. So there's three main operations for GraphQL. One of them is a query. Basically, it's just like getting data, just like you would do in any query scenario, REST scenario, or wherever you're just getting some data. A mutation is where you're modifying, whether it's inserting or updating. And that's just where those types of calls is where you're going to change data, create it, so on and so forth. And a subscription, which we won't really go over too much in this. A subscription basically creates a permanent connection from your application to, or sorry, I may say permanent connection from your application to GraphQL, so that GraphQL can then watch your databases for changes and report those changes back to your application in real time. It's a little more complicated. I have a basic example of how to set that up, but I'm not going to go into too much of it. We're going to use WebSockets to pull that off instead. So fetching data using queries in GraphQL. Like I said, it's not too complicated. So on the left, here's how you would do it normally. If you were to write a query, you get your data, you get a couple rows of data back. Doing the same thing in GraphQL on the right, you send it JSON. In this case, you're sending it, I want a user with an ID of 1. And the only things I want back from this user are the name, email, and the orders as an array with the order total and the ID. And that's how it would come back. Now, the beauty of this is you're getting far less data back from a simple query than you would using or from the GraphQL request than you would from the normal query. Because if you notice, like, the name and email is duplicated for every row. so on and so forth, where in the GraphQL request, it's not. You just get that one piece of data back. So it definitely gives you far less data traveled across the wire from one place to the next, and allows you to easily go through it all too. It makes it far less complicated to run through your data. So how that would look like in ColdFusion. So at the top, so you have to install the GraphQL package in ColdFusion. Make sure you install that, obviously. And once you get that running, all you have to do is do git GraphQL client. You give it the whatever you're going to call your client, and the service URL and whatever the root package is inside GraphQL. So that's when you set up GraphQL points, their internal packages, and you just have to make sure you point to the right package, and that will have where your data, that package knows how to get to your data you're looking for. So in this one, we're using the query call here to the launch details data set inside it, and we're telling it the ID is 110, and then we just basically execute and then get it. And then at the bottom, you can see the dump of the result from GraphQL. So like I said, it comes back at JSON. And this one, we basically got everything. We didn't tell it to only give me certain things. We just said, give me, since there was no indicator as to what I wanted back, it by default says, give it all to you. So it gave me everything that was attached to this user. Now, this is a, service URL I'm using is a test endpoint that anybody can use for playing around with GraphQL and getting data. So it has some odd, fun data to play around with. I think the one currently it has like launch data and fun stuff like that. So that's kind of the basics of how to do it through ColdFusion. Not too complicated, pretty simple. There's another way to get the data, though, that's a little more robust and gets you a lot more finite. It allows you to really finite the data down and do a lot of different things. So instead of using query in this example, we're using a function called fetch response. And we're going to basically build our JSON inside that and basically send it across. Now, yes, it's not JSON as you would think about it. It's basically a string that's processed that contains JSON, but you're telling it that in the fetch response that I'm running a query against the launches function, and I want to launch with an ID of this launch ID, and this is the information I want back. So it allows me to finite down what I'm really looking for. And then on the right, you can see the dump of the data that I got back. So we got the launch, and then inside the launch was the rocket and the rocket's name. So gives you a definite idea. And in this one, if you notice, I didn't have to do an execute. It's just a straight get since I'm using fetch response, so it makes it a little cleaner. I actually like this method a little better because you can actually be a lot more finite in what you're doing. Here's another example, but this one we're getting multiple launches, and we're going through page sizing. So we're telling it how many pages we want. We want to start after, and we want a page size of 5. So it's going to give me the first 5 rows. This is actually a lot faster because when you build this out, you're going to get the cursor ID, which you see on the right here. So we get this cursor number, and then later we're going to reference that for future calls, because the GraphQL maintains that cursor on its side so that it doesn't have to go refetch that. It's already grabbed it all, and it's only giving us a part of it. So then when we reference that cursor, we can actually get the next page and the next page and so on without it querying data or possibly getting different rows because the query may have changed since the initial request. So this allows us to go through that a little bit better. And again, there's not much just changed in the before in this, just still setting up the parameters and running fetch response. So now we know how to get some data. Let's look at how we update the data. So changing the data, you do it through a mutation. Like I showed earlier. So instead of using a query, we use a mutation. And in this, we're using, on the left, we're using create product. And we're giving it the name, the price, description. And the bottom part, ID, name, price, is this is what we want to come back. So we're saying create on the top section where it says create product, name, price, description. The bottom part is the return. So on the right is our expected response. So we would create the product, it would give us an ID and the name and the price. Now, again, your application doesn't need to know where this data is going. This could end up actually be spread out amongst 5 different databases. Who knows? Doesn't matter. GraphQL is just is configured on where to take all this data, and it knows how to send it out there to where it needs to go. And then your expected response is basically it queries it back and gets the response that you're looking for you, because you obviously maybe want the ID back. And that's an easy way to get, if you have multiple databases storing multiple pieces of data, it's a great way to sometimes spider out all that data to multiple servers in one shot, because you don't need to configure your application to do it. So what it looks like in ColdFusion, it's pretty much the same as I've done before with the query. So here we're just doing instead of a query, it's a mutation, and we're calling the mutation function with the data we're going in. And in this one's a little different. So we're sending the email in ID. So we're updating the user's email to a different email address in this one. So on the right side is the response that we got back with the updated change to the data. Pretty straightforward. Nothing really special. Just in and out. So subscriptions, like I said, we're going to talk about this briefly, and I'll tell you why I don't like to run them in ColdFusion. So subscriptions, they're basically live data streams from the server when specific data changes. So you subscribe to the data using a query. So this is the query of, let's say, names and email addresses that you're querying, and it creates a subscription to that data. So whenever any name or email address would change, your endpoint would get a notification that something changed. Now, it does do real-time pushing of the data back to the client. So as things change, you get it back. It definitely eliminates the need for polling and all that other fun stuff that you'd normally do. But I'm not a huge fan of doing this in ColdFusion, to be honest with you. I'll explain that in a second when I show you some of this code. So here's the code to do a subscription in ColdFusion. So basically, you have your GraphQL client. So at the top, we have get GraphQL client with just a name. So in this occurrence, we've actually configured the client in the ColdFusion administrator. It's not done in the code. That way, it's persistent. We don't have to reset up that every time. It's already preset. And then we create the subscription to the trips booked endpoint in that client. And then we have all the functions that are going, the on connected, on success, error, completed, terminated. And then at the very end, we execute with all those functions. And then we sleep the thread. And this is where it gets dangerous in ColdFusion. So ColdFusion doesn't like to have long-running permanent threads that sit out there. The only way for subscriptions to work is you need the ColdFusion thread to stay running. So what you would end up doing is this thread would sit there and sleep for 5,000 milliseconds, and it would just sit there and as a ColdFusion thread just sit there running. But it has to stay running because it's the subscription endpoint that needs to get data back. So it needs to get that data back and sit there and stay functional. Now, the only way for this to actually stay functional and stay working is this thread needs to stay alive. So we sleep the thread forever to keep it alive. Now, in sleeping the thread, we do end up eating ColdFusion resources to do that. Because, yeah, there's a dead thread sitting out there doing something. So then you have to do thread management and manage this thread that's running and deal with that. So you can either use CF thread to create a never-ending thread, which is dangerous, can lead to a lot of memory leaks and other issues, or you run this as a schedule and you basically keep refiring it over and over and over and resubscribing. So you basically let it sleep, and then after the end of the sleep, you basically get it to fire itself again, because the thread has to stay there. Now, the downside of doing all that is if there's anything that happens in between your thread shutting down and your new thread starting up, you're going to miss something that happened. So that's why I'm not a huge fan of doing this subscriptions in ColdFusion, although you can. just not a fan of doing it because it just doesn't pan out in the way I would like it to, and I think it's just too much of a strain on servers to do it. So now that we kind of understand the basics of GraphQL, let's talk a little bit about WebSockets. For those that don't know, WebSockets allow you to maintain a persistent, full duplex communication between a client and a server. It allows for real-time data exchange. You can send and receive data from the client, pushing changes from the client down to the server, and vice versa. So your clients can respond to real-time events on a server. And ColdFusion has it straight built into it. You'd have to install or add the in 2025, you have to install the WebSocket package. Once you get it going, then you configure the server. Start it up. You can use secure, all that other fun stuff. It's all built in. And it makes it super simple to use. It's not complicated. It's only one tag and one configuration in your application CFC to basically turn it on. And then you can send and receive data in real time from your client to your server. It's very nice, and I use it for a bunch of stuff. We'll show a really cool use of it here in a little bit. And I'm not going to go into the nitty-gritty of setting up WebSockets. There are plenty of presentations out there that will definitely show you how to do that. So go dig up those. I'm not sure if there will be one later through this online summit. I think there is, and it'll go over how to build WebSockets and set them up from scratch. So if you're interested, take a look at one of those. So assuming we set up WebSockets properly, and we wanted to push some data out to a client. So here's some example code of how we would basically simulate a real-time data feed and push data out to a client. So what we here have is we have the WebSocket channel, which is set up in the application CFC. Basically, we're getting a JSON data file and reading it. And then we're just, in this code, we're just looping through a JSON file and publishing the data out. And we use WS publish down here to actually publish the data. So we're publishing it to the channel, and we're basically serializing every row in the JSON and pushing it out one by one. Pretty straight, simple. And then you need something on the client side to then process that. It's all written in JavaScript. So you have to write some JavaScript to process the incoming WebSocket. And I'll show you kind of how that kind of works for the little demo we got a little bit, and how I kind of siphon all that together and see. Pretty cool. So if you're using Chrome or any other browser that you can open DevTools for, you'll actually get in the network panel, you'll have the messages tab, which will show you all of the WebSocket data coming back in and out. And so for ColdFusion, basically how the client would connect is you have the CF WebSocket tag, what the name of the channel you're connecting to is, and the on message is the JavaScript function to handle the incoming data, and the subscribe to is what subchannel you're subscribing to on the server. And in this occurrence, we're subscribing to the game events channel to get and anything sent to the game events channel will get sent to us. And then the function, literally here, we're just logging it out into the console. Nothing special here. But if you see on the right, here you see this is all the raw data coming back that you would see in your DevTools for it. So CF charts. So ColdFusion 2025 got a nice update and got the latest, greatest version of Zing charts, which has some pretty cool features in it. A lot of HTML5 based solution, a lot of new charting features, writing on far less code than prior, a lot of new functionality. You can do seamless data binding between your client and the server. We can constantly refresh, so on and so forth. There's a lot of different chart types, even more that were added, as well as theming. So the new additions to 25 are really cool for when it comes to charting. A lot of new things in there. Make it really, really cool and a useful tool. We'll go over some of that. So to create a chart in ColdFusion, it's kind of, this is the code to do it. Pretty simple. You will have to install the chart package to do it. But once you get that installed, then you're basically writing, if it's all HTML, it's all tag based. So for those script aficionados, yeah, your UI is tag based for this. So it's the way it is, unfortunately. So you have CF chart, and this there's the tag, the outer tag, and then the basically how you're configuring the chart. There are other ways to configure the chart through JSON, so you can actually give it a JSON string to configure the chart instead of doing it this way. So there's a couple ways to do it. And then every chart needs a chart series, which is basically the data. So in this, we're just creating a random chart of data from 2015 to 2025 with a random number in it. And then at the bottom, we're doing a little bit a bubble chart. So the first one's a bar, second one's a bubble. Just making a couple random charts just to show off some functionality and kind of how they kind of look if you were to make the chart. So the top two are the ones that were in the code prior. The bottom two are some other examples you can do, like a pyramid and a radar. So there's a lot of different. Let's see really quick. If somebody said it feels weird that it's just tag based when the latest push has been for CL script. Yes, but you should tag. Yeah, like Mark said, tags are for output. So if you're doing stuff to the browser, that should all be in your view. Should generally be tags for the most part. It's your other stuff that's all generally script. Where's the data connection made for CF chart? I will show you that. So, and with theming, you can take those basic charts and make them look a lot prettier. You can create your own theme files and everything. So you can take what used to be these basic white and blue charts and make them considerably prettier. And they look a lot better. Obviously, I am not a graphic artist. Never claimed to be. I don't do pretty. I implement pretty. So if you have a person that's really good at CSS and stuff, they can make you really cool themes and make your charts and graphs look pretty cool. So now that we've gone over everything, all the basic premise of all the technology that's involved in all this, let's take it all and put it together into something cool. So circling all the way back. So the task at hand is getting data from the video game, putting it in a database, using GraphQL to react to that new data, and then displaying in a dashboard. So how that kind of functions through in the flow of data. So Apex Legends has the ability to actually have a real-time output data feed of the game as it's happening. So if you've ever watched any pro league games or any video games that have tournaments and stuff like that, a lot of these games have this pre-built in where they can real-time send out data on the game as it's occurring in real time. So they can update placement charts and things a lot like that to show what's going on in the game. Apex has the same thing. So what Apex has the ability to do is you can point it at a WebSocket endpoint, and it can then transmit its data to a WebSocket, and it can receive that data. And you can use that WebSocket to then store that data, which what we did is we stored that data in the database. So as the game is going, WebSocket retrieves it, it processes it, the JSON, and inserts it in the database. And then we use GraphQL to subscribe to that table that it's being written to. And then it grabs that data as it's inserted and transmits it using WebSockets to the client that's looking at a dashboard. And then using CF charts and dynamic chart display, we then take that JSON data coming through and display it in some highly visualized charts so we can literally watch a video game as data. So how this all kind of goes together. So CF chart for displaying it is kind of the crux is one of the big parts of this. The one main part that I will tell you is this doesn't exist in the built-in version of ColdFusion for CF Chart. You can do it, and I'll share the code to actually do it. You have to manipulate the underlying features of ZingChart to pull this off, which actually isn't that hard. And like I said, I'm going to share the code to make it happen. So if you ever want to make real-time charts, it's actually really easy through WebSockets, and I did all the hard work for you. So CF Graph. So the question was, CF Graph works through subscription? Not really. CF Graph is responding to WebSocket. The WebSocket is subscription. CF Graph is just responding to WebSocket data. So you can, however, point CF Chart at a data URL or by polling, but for what I was trying to do, that was just too slow. I wanted it to be real time. So then what I do real time was have the server push it out using WebSockets. So I didn't want to do polling or anything like that. So, and like I said, I will show you exactly how to do this, and it's pretty cool. So starting off with, let's take a look at our source data that we get in. So the source data coming from the video game is kind of crazy. Every row of data contains a ton of information for to be processed. So everything can be kept track of. So everything is all of it for every single piece of data. It's the player that initiated it, what their team is, their X, Y, Z positioning, not only where they are, what direction they're facing, their current health information, all this other stuff. There's a this is what they call a nucleus hash, which actually you can take that hash number, and search all of the data for it, and you'll find everything that this exact player did or was affected by. So it's a nice way to identify everything in that condition. And this example we're looking at is a player switched their weapon. Yes, even stuff like that is transmitted because the other clients need to know. So not only does this data get sent out for processing for dashboards, this is also the same real data that's actually transmitted between the clients that are playing the game. Because for those that don't know, a video game, something like Apex, is actually played on a remote server. The clients are just viewing what's being done on a remote server. So the clients need to know what's happening. And that's how they know that somebody switched their weapon, because they need to visually see it. And then you get the timestamps of things are done in order, so on and so forth. It gets really complex. But this is kind of just the bulk of data that's cranked across. Now, I'm going to go and show you the how the real-time graph code works. If you want to grab your phone, grab the code there, you can actually look through the code with me. I'm only going to show part of it in the presentation, but that's where all the code resides. It's one big group of code, and get one file for you to look at. It's all JavaScript. Don't laugh at my JavaScript. It's not the best, but it's not the worst. Give me a second to grab that for those that are interested. All right. So the real-time graph code. So the first part that I had that ran into is trying to insert the data into the graph. And I found out that in order for it to work, thank you for grabbing the URL for everybody. That is case sensitive. So if you didn't grab the case of it, that may not work. But at any rate, the graph setup, the chart series needs to be blank. So you start with an empty chart series, so that it creates that. So that object is created in JavaScript, so you can bind and load to it. So the first thing we do is we create a bind object, and then we immediately unbind, because we want to prevent the bind from calling itself, which can happen. So we unbind. So once we bind it, we create and execute and create the chart and set it all up. So then we have a data object that we can attach to. So then on the right, the WebSocket handler, so it's receiving data coming in, and it's looking for a specific thing in this occurrence where it's looking for the category of player damaged is the data coming in, and we have a data attacker and we have a damage inflicted. So we're making sure that it's not that a player was damaged by environment, and we're excluding where the attacker is environment. We want to make sure that there's actually a person doing the attacking in this occurrence. So then we look at the character information. We grab the amount of damage inflicted. We have to. This is particular to the data I'm getting in. We had to parse the int, do some other stuff, and then we update the damage chart and call this function update chart. We give it the legend of the damage, and then it runs it through. So I don't think I have that here. So this update damage chart, actually, I think I do. Yes, I do in the next slide. Sorry. So update damage chart that we're calling. So going back really quick again. So this player damage here, at the end, we're calling this update chart with the legend and the damage that just happened. So update damage chart, this is where kind of all of the magic happens. In here, we're passing in the legend and the damage. What legend did the damage, and how much was it? So what we do is in here, we're creating labels and values for all of the damage, because the way the Zing chart works is we're going to feed it in the full data set every single time, not just the update. We're going to give it everything every single time. And we're going to give it all the new data, all the new values, all the labels, everything every single time. And we're going to tell it, and that's what these two Zing chart execs are. Basically, we're setting the values, and we're then telling it to modify the chart. Here's all the new values, modify it, and then animate it. So Zing chart naturally has the ability to say, oh, you already had data in here. You're giving me a whole bunch of new data. Okay. And you want to animate it? It'll animate from the old data to the new data instead of just doing a direct wipe over. And then we're just basically setting some information here on angles and labels and stuff. Because remember, since we're resetting everything every time, we have to reconfigure the labels and bar widths and everything every single time. So it's kind of a little bit of extra code, but it allows the chart to build and display in real time and fully loading all the data. So having done all of that, we're now going to, unfortunately, hopefully this will work, and I'm not sure how well this will come over on your end, and I apologize if it doesn't look well, but we're going to watch a quick 30-second video of an entire 45-second video of an entire 25-minute game of Apex cranked up full speed and ran in less than a minute. So this is the capture of how the data came through, just sped up drastically. So let's see. Hopefully this doesn't look too bad. It doesn't look too bad. So here's the data coming through. In the top graph, you see all the weapons that are used as they occurred. The bottom left is the legends that have been killed in the game. And the bottom right is all the damage done by each legend themselves. In this occurrence, we're not tracking which player damage. We're looking tracking at what legend actually did the damage, so we can see which characters were the most deadly, as well as environment. So who took the most environmental damage, zone, stuff like that. So as this cranks through, so you can see in the match duration in the top right corner how long this match took. So that was a match that took 23 minutes and 29 seconds, sped up to completely crank the entire game down to 38 seconds of data. So, yeah. Yeah, Bloodhound's got the ability to scan and find people pretty easily, so they're pretty brutal. So that's a video game, a 23-minute video game round played out in data. So again, how that was pulled off is the video game sent data to a WebSocket endpoint that was inserted into a database that GraphQL watched for, grabbed the data, and used WebSockets to spit it to a client to display in a pretty graph. So now let's look at this in a different way. So while that looked impressive, Nope, let's not do that. So while that looked impressive, let's look at it with the DevTools open and see the flood of data that actually comes to the client when this occurs. So the same thing, same processing, but now the actual data flood. So one game is roughly 100,000+ lines of JSON that are getting spit through. It's a lot of data that comes through really fast. And yes, this was simulated. So I was actually reading a JSON file and blasting it back. But I'll pause this really quick and you can see how quick these times are. So I'm getting tons of rows per second coming from a server to a client. And yes, clients can actually process data this fast because it's very minimal load. I didn't notice any processor spike when this was happening. So it was actually cranking these rows pretty quick. Granted, this is, like I said, massively accelerated. Normally data in the game would not come through this fast. But I was simulating the event. So you can see how quick this data is all flying through. Lots of data in a short amount of time. So, like we said, so the crux of all this is ColdFusion being the great orchestrator that it is for allowing multiple systems to interconnect with very minimal usage, not really much to do, pretty easy. GraphQL was in play. Yes, every hit, every miss, every damage is captured in real time. That is correct, and transmitted. Some events are grouped. So like if you shot your gun for 5 seconds, that would all be grouped into a single push. But yeah, all of it. So like I was saying, GraphQL is there to respond to real-time data inserts. And WebSockets was the other key point where it allowed not only the game to push data to a server, but it also was used to then push data from server to client. So a lot of directly connected things. I will say that for the purposes of, if I was to build this without trying to build it for this presentation, this is definitely over-engineered. There are some things you could skip out from, not do, to tighten it down. But it was more of, hey, can I do this? Was the end of the day. And that's kind of all of that. Any questions? I think there was one question about GraphQL back. Does it sit between the client and the database, or the backend server and DB? So it would sit behind your application server and whatever it wants to connect to, whether it's a database, REST endpoint, and so on and so forth. Let's see. Does Adobe have plans to support GraphQL as a server in addition to a client? The ColdFusion implementation of GraphQL reaches out to existing servers, so I'm not sure. Setting up a server, as somebody has tried to do it, is not as simple as it sounds. I will let Mark take that one. Go ahead.
Yeah, so I can answer that real quick. We have it in our long range plans to potentially allow that to become a thing. It's like Dave said, non-trivial. Setting one up is extremely complicated and complex. You can do it today. We actually ship with all the programming code that is required. You just have to do it manually. There's no ColdFusion-y way to do it today, but you could technically run a GraphQL server off the back end in front of ColdFusion code if you so desired. Our engineers have done it. So that's the answer.
Let's see. Somebody said, with all this data, why is it hard to catch hackers? I do not have enough time for that answer. That is a very complicated answer, and if it was easy, they would be caught. Let's just put it that way. Catching hackers is super complicated, like very, very, very complicated. Because if it was easy, there would be no hackers in any video game ever. So as much as hackers annoy people, keep in mind that, like I said, if it was easy, they wouldn't be there. Let's see. Never use WebSockets, GraphQL, CF chart. Any other questions? I know there was a lot in there. A lot I went over. Happy to field any questions you got.
Just a reminder, Dave, we have the $50 gift card that you could give away.
Yes, that's right. How do we give that away? That's a good question. How do we give away the gift card? Trying to think of a good way to give it off. Nothing's coming to mind right off the top of my head. Can we just give it to one random person that's here, Mark?
Yes, you could do that as well.
Yeah, just give it one random participant. Congratulations. Just make it simple. I could ask you a question about something in a presentation, but it's easier. Just give it to somebody random. Let's see. The other question was, can operating system run a daemon for the subscription? You could, but you still have to have a CF thread running. There's other ways to do it without that, but it gets a little complicated. But yeah, something needs to be running for that subscription to function. Can I log off and back on as random? That's funny. Never thought of that. All right. Anybody else got any questions? We're running low on time here. We got to do this presentation right after mine, if I recall. All right. Well, if nobody has any other questions, you're all very welcome. I hope you learned at least one thing. I learned a lot making this presentation. Yes, these are all being recorded as far as I recall. And don't forget, there's more presentations throughout the week. And CF Summit is coming up in Vegas later this year. So hopefully I'll be there, and hopefully we'll come say hi to me there. If you have any questions, you can ask me then too, if I'm there.
Thank you, Dave. Thank you for the great session.
You're welcome. Thanks, everybody. Enjoy the rest of your sessions.